Hi everyone, I'm Alok and welcome to Next in AI. So, in this video, we will solve this optimization problem, which is a minimization problem, and we will solve this using Python. But for solving with Python, we will use library, which is very world fastest solver, which is Gurobi. And in Python, they have an API called GurobiPy, so we will use that and we will solve that. So the first thing is that we will import our library. So first of all, what is our problem? So the problem is here that we have to minimize this function z is equal to x plus y plus 2z, which is subjected to the constraint x plus 2y plus 3z must be less than equal to 4 and x plus y must be greater than equal to 1. And non-negativity constraint are like x greater than equal to 0 and y greater than equal to 0. So the first thing we will do is that we will import our library. So first of all, we will import our library. So to import GurobiPy, just type import GurobiPy as GP, and we will import GRB from GurobiPy, which is basically used to add different type of constraint and different kind of objective sense and everything, right? So let us import grb from GurobiPy, right? So first of all, let us run this. So now it has finally imported. Now the next thing which we have to do while solving any optimization problem using GurobiPy is, first of all, we have to define our model, right? So from GurobiPy, we have to define our first model or whatever model we want to define. So the second thing is that we have to define model. So to define the model, we can assign a certain name to the variable, and we can import our model from GP, right? So and we can name our optimization model or anything. It is not required, but it is better to name it, right? So now the model has been created, right? So once the model has been created, first of all, please make sure that you take the license and you install the software. Okay, so this is your academic license. You can take as per your need whatever license you want, right? Now let us move to defining variables. The next thing which we have to do is we have to define our variables, right? So we have total three variables, right? You can see here that we have x, y, and z, right? So these are three variables. So the first one, x1, which is x, can be defined as, for defining variables, we have to add vars in our model. Let me show you how you can do. Like m is our model, then in m we have to add vars, which is a we have to add m dot add var, and we have to define our variable type, right? So the variable type is either as we know that in optimization model, the decision variables x, y, and g are decision variables. This is our objective function. These are all constraints, and decision variables can be continuous variable or non-continuous variable like integer variables, right? Or binary variables. So these all things has to be defined here, right? In this variable type we have to define. Okay, so first of all, I am defining variable type as continuous variable, right? So it can take any value. Okay, any positive value, because we have already defined this non-negativity constraint. Okay, so grb dot continuous. Okay, let me see if it is correct. CUNTI. Okay, it is correct, and we can name the variable whichever name we want to assign. So this was x, so we can provide it as x, right? The same way we have to define for y and g, right? So this is sorry. So this is for y, and I'm editing it. So now, sorry. So this is So this y has been defined now. L- Let me change this. Yeah. Now y and x has been defined. Okay. The same in the similar way we can define our g variable, right? So now the g has also been defined, and I'm setting all the three variables as a continuous variable, and it can take any positive value between 0 and infinite, right? So once you have declared your variable or defined your variable, the next thing is that we have to define our objective, constraints, or no, we have already defined our variable. Okay, so the next thing is that we will either define this objective function, or either we can add constraint. So it is always better that you add the objective function first, and then you add your constraint. Okay, as so once let us add this variable. uh, Sorry, yeah, the name I have written is in capital, but it should be in a small. Okay, so let us change this. Now we are good to go. Yeah, we have finally successfully defined our variable. Then we will set our objective, right? So the next step is setting our objective. So to set the objective, first of all, we have to see what is our model sense. The model sense here is that we have to minimize this objective function, right? So the model sense here is minimization, right? So we have to write the model sense. Here, just one note here. uh, For variables, we have added continuous variable. If you have integer variable, then you can type grb dot integer. Okay, if you have binary variable, then you can type grb dot binary. Now let us move to set our objective. Okay, so to set our objective, we can set it as following: model dot set objective. Okay, m dot set objective, which is our model. Okay, and our objective is x. So we have already defined our variable x. You can see here. So x, we can use x plus y plus 2 times of g, right? And our model sense is grb dot minimize. Okay, if it would have been maximize, then it would have been written as grb dot maximize. Okay, so since we are minimizing our model, minimizing our objective function, so we can use m dot set objective and grb dot minimize. Okay, so once the objective is set, then the next thing is that we have to define our constraint. Define our constraints. Okay, so to define our constraint, we have total two constraints, and by default, the non-negativity constraint is defined by default, so we don't have to define these two, but these two has to be defined. Okay, so the first constraint is c1, we can add, and c1 is m dot. Okay, either you can define this value, or you can directly, no need to define, give a variable name to this constraint. Add dot cons tr. Okay, so this is the command for adding constraint to your model, to our model. Okay, so the first constraint is x plus 2y plus 3g must be less than equal to 4. So we can type it as x plus 2 times of y plus 3 times of g. 3 times of g must be less than or equal to 4. Okay, now the next constraint is the next constraint is x plus y must be greater than equal to 1. Okay, so for that, we can write it as x plus y must be greater than or equal to what? 1. Okay, so once the constraint has been defined, okay, so now finally the constraint has been added. Now uh, we can optimize our model. So to optimize our model, we can use the command m dot optimize. Okay, so once we will optimize it, then you can see that we have successfully optimized our solution. Okay, so we have successfully solved this problem, and you can see what are the values of x, y, and g. So x can be, you can simply see x has the value 1, y has value 0, and g has value 0. So for for these values, the objective function z has been minimized, and to get the objective value we can see, use the following command: model dot get objective. Okay, so m dot get objective will give us the objective, whatever is the value for our, sorry, model dot get objective dot get value. Okay, so yeah, you can see that the objective function value is 1 at x is equal to 1, y is equal to 0, and g is equal to 0. Now if you want to access these values, how you can access these values? Okay, so to use that, you can use x dot x command. Okay, so x dot x will give this value. Okay, now similarly you can use y dot x. Okay, so y dot x command. So y dot x will give the value for y, and g dot x. Okay, g dot x. So this will give value for g. The dot x is by default, the dot x is used to get the value of any variable, right? See, you please don't get confused by this x value, this x and this x. Okay, so dot x dot x is, since we have defined a variable named x, and if we want to get this, the value of this x, then we have to simply use dot x. Okay, similarly for y variable, if we have to get the value, then we have to use dot x. Okay, so this dot x is not same as this x. If we would have been any other variable like x1, then we would have used dot x. Okay, so please don't get confused by this x, this x and this dot x. Okay, so I hope you learned how to solve optimization problem using this GurobiPy. This was a very basic problem. In the next video, we will solve a problem which involve looping and all. Okay, so thanks a lot for this video.